Okay, question 5 is a modelling question with quadratics. So we've been given a quadratic for the height of the arrow above the ground. If we kind of picture what's going on with this, we could kind of draw set axes. So that would be your height above the ground and your horizontal distance d. Now if we imagine this has been shot up into the ground, it could start at the origin, might not necessarily, we can check this out. There's actually kind of answer to one of the questions. It would have this kind of motion. So we're going to work with this equation that they've given us. And the first question says, given that the arrow travels in a vertical plane until it hits the ground, find the horizontal distance travelled by the arrow. So that is to say, when it hits the ground, the height is going to be 0. And what's the distance going to be? Well, if we use that equation, so when h is 0, we get 1.8 plus 0.4d minus 0.002d squared is equal to 0. So this is a quadratic that you can solve. However you want to solve this, you can put it directly into the calculator, you can use the quadratic formula, either of those would work. So if I were to use the quadratic formula, b would be 0.4 and we'd have b squared minus 4ac. Just make sure you're getting all your signs correct, over 2a. And that will give you an answer of about 204 metres. So that's to say, when we hit the ground, we've travelled a distance of 204 metres. Part B says, with reference to the model, interpret the significance of the constant 1.8. So if you look at that original equation, we consider, well, what is the importance of this 1.8? Well, if you set d to be 0, then we get h coming out to be 1.8. So that's saying when the horizontal distance is 0, we get 1.8, which is basically here at the beginning of the archer shooting the arrow. So what I've drawn here is not quite correct then. It actually means that it starts above the ground, and that would be the initial height of the arrow. So the initial height of the arrow above the ground. Alright, and part C then says write this in this form. So what you should be thinking about in that is this form looks a bit like completing the square. So that's basically what they're asking you to do, is can you complete the square? It might help you to rewrite it in this order, because that's how we're used to seeing quadratics. And completing the square on that, well, we probably want to pull out a 0.002 or minus 0.002 from that. And I'm going to pull it out of this bit only. Actually, if I pull it out of 0.4, I divide 0.4 by 0.002, it is minus 200. I'm going to leave the 1.8 though, I don't need to mess around with that. And then I'm going to complete the square on the bit in the square brackets. So just this bit. And what I get then is d minus 100 all squared minus 100 squared to complete the square, and I get that. So that's starting to look a bit like this form up here. All I've got to do is sort of simplify all of this now. So I will get minus 0.002 d minus 100 all squared. Minus 100 squared is minus 100,000, and times that by minus 0.002 is plus 20. and then add 1.8 at the end, and then I'd get this, plus 21.8. And so that's in the form that they want it above. Okay. The final part says it's decided that the model should be adapted, and we've got this. Now what you need to notice is the difference between these two equations is simply the constant has gone up by 0.3. So it says, hence or otherwise find for the adapted model the maximum height of the arrow above the ground and the horizontal distance at that maximum height. So all that's happened is everything has gone up by 0.3, because if we were to draw that, instead of starting at 1.8, we've now started at 2.1. So the maximum height here is going to be 0.3 higher than it was before. How do we find the maximum height? Well, we need to look at the complete the square form. So this is why they've asked you to do that, because they wrote hence. You could do it any other way you like, so that's the or otherwise bit. But hence means I could use the previous part and say, well, what's the maximum height of that? To find the maximum point, we could look at this constant on the end. So the maximum height of the original projection is 21.8. So the maximum height for our new projection is going to be 21.8 plus 0.3, which is 22.1. It says find the horizontal distance when that happens. So when is this all equal 21.8? It's when this bracket here is equal to 0, and therefore d is 100. So your horizontal distance won't actually change, because remember we've only added 0.3 to the equation, we haven't done anything else. So the horizontal distance will still be 100.